So we were saying we talked about this last time. If you remember your college algebra, looking at a two-dimensional graph from the left to the right, you can tell where it's increasing and where it begins to decrease, right? So
Right.
right here we have a slope of 0. Over here we have positive slopes, negative slopes, and what we've been talking about, right? Using derivatives, we can tell where exactly our slope's going to be decreasing. Just keep on going. So these peaks and valleys would be our critical numbers. So what we did last time, we found them. So what we're going to do is find the critical numbers and test around them. So the first few questions is just going to ask you, okay, where are we increasing? Where are we decreasing? So you can kind of see it. We're increasing from here all the way to there, and then decreasing from here to there, then increasing again, right? So you can write intervals to find out where that's happening. So for the first example, let's get started here. Identify the open intervals on which the function is increasing slash decreasing. Here's the function f. We'll start with something really simple, just a parabola, because you can already figure this out without calculus, but we want to do it using derivatives just so we can practice. Okay. So step one, find f prime. The derivative will be, what is our derivative?
Six
1 minus
x
6.
minus 6. No. 2x minus 6. I'm sorry.
Yeah, 2x minus 6. So there's my derivative. Do y'all remember how to find critical numbers?
Um, don't we
The function equal to 0.
Yeah, we got to set the derivative equal to 0. So f prime equal to 0. That's what we're going to do. So add the 6, divide by 2. There is the critical number. That was from last time. Okay. So we're going to use the first derivative test to find out where we're increasing, where we're decreasing. But as you can tell, right, with this picture, if we know that we're increasing and then decreasing, we're going to have a maximum, right? So just seeing what happens around the critical will tell you what it is. They didn't ask for max or min, at least not yet, but that's where we're headed. So we'll probably end up doing it anyway, just for more and more practice. So step 3, use, you know what, I'll probably do on the next page. Yeah, cool with the first 2 steps.
yes.
Okay. I still need to send y'all notes from last time, so forgive me, I'm a little behind.
Wait, could you go to the previous page? I haven't finished writing everything down yet.
Yeah, no worries.
Okay, go ahead.
All right. So we use the first derivative to test around the critical point. Or I guess you say the critical numbers. To determine if it's a max or min. So doing this, finding the max and minimum will also give us the increasing and decreasing locations. So just do it all at once. So this is the first derivative test right here. Our critical number was 3, right?
Yes, sir.
Okay, so pick any number before the critical number, any number after.
Let's go with 1 and 5. Do those
Okay.
work?
Yeah, as long as it's not 3, we're good. So the derivative was 2x minus 6, right? That'll be negative 4. Be at 2 times 5 minus 6, positive 4. So here are the points that we chose. So over here we're positive. Over here we're minus. So what I want you to picture is everything before the critical number is decreasing. And then after the critical number, we have a change and it begins to increase. So now we're going from minus to plus means we have some sort of minimum type critical number. You see how you determine it? So this tells us that there's a minimum at 3, comma, whatever the heck 3 is. We gotta find that. There is no max. But to find the actual value, you gotta plug 3 into the original. The original was, let's see, squared minus 6, right? Yeah. Be 9 minus 18 minus 16. That's 25, right?
Right.
Okay. So here is the minimum point. Now, it didn't ask for any of this, but this is what we're gonna end up doing over and over again. Okay. Now, looking at this graph or this little number line right here, we are decreasing from negative infinity all the way up until 3. So now we can actually answer the question. Decreasing from negative infinity until 3. Increasing from 3 until infinity. So once you have this, once you test around the critical number, we know it's not going to change again. It's not going to begin to decrease again because there is no more critical numbers. If there was another one, then you could say, okay, we got to check. Maybe it'll come down or maybe it'll keep going up. But since there are no others, we can assume that this will be true. Does that make sense?
Could you say it again, please?
Yeah, here, let me graph this so you can see it, and then we'll say it one more time. X squared minus 6x minus 16.
I'm confusing like decreasing is like minus infinity and 3. How?
One moment. Make the whole thing go. Hold on a sec. Computer being weird. Okay. Can y'all see so this is the graph we're working on, okay? So we found the critical point right here at 3. So this was found with our derivative set to 0. And even without calculus, we should have already known that's going to be the vertex and the minimum. So the reason we're doing this, right, is because this works for any function. And eventually it'll be too hard to graph, so you can figure all this information out without graphing it. But anyway, so if you plug before the 3, any number before 3 into the derivative, we have to remember, what does the derivative do, right? Derivative gives you slope. So any number I choose below 3 is going to have negative slopes, which means it's decreasing for any number below 3. So that's why I said pick any number below 3, because it's not going to change until you hit a critical number. After the critical number, you might have a change, right? It might not, it's not guaranteed. It could stay decreasing or it could begin to increase. This one we already knew because it's a problem. It has to start going up eventually. So we tested any number after 3. That'll tell us that anything after will be increasing forever because there are no other critical points. There's only one critical number. So when they ask us the question, where are we increasing, where are we decreasing? So you can just say, well, everything below 3 is decreasing, everything after 3 is increasing. Does that make sense?
Yes, it makes sense. Thank you.
So that's why we get this right here. So we picked, right, any number below 3. The derivative gave us a negative at 1. So we said, well, that's going to be a minus, meaning we're decreasing below 3. So this tells us right here that we're decreasing before 3. This tells us that we're increasing after 3 because it's positive. So the sign of the value tells us if we're increasing or decreasing or increasing. Okay, and if we have a change that goes from decreasing to increasing, then that tells us that there's a minimum. Okay, if it was increasing to decreasing, that would be a maximum. Since there's no more critical numbers, we don't have any more extremas to talk about. Okay, so that's the big picture of what we're going to be doing. We're going to do a few of these, but that's what we're doing. You have any questions on the first one?
No, we just in the test we should graph it, or we can use the decimals.
You don't need the graph. You can use all this to graph by hand. The graph is just to show you visually.
Thank you.
Okay, let's do another one. Because eventually what you're gonna do is use all the techniques from chapter 4 to sketch a curve. So we're gonna pretend graphing calculators don't exist, and you're gonna use all these calculus techniques from chapter 4 to give a rough sketch. That's the main. Once you can do that, then you've mastered chapter 4. You can do a sketch using these rules, and you'll be good. It's a great question to practice chapter 4. Let's do another one. Okay, so part A, find the local max and min. It's problem 8 from the homework. Problem B, or part B, find the intervals for increasing, decreasing. All right. So step 1, I'm going to try to shorten the steps a little bit, not too much. Find the critical numbers. So combining 2 steps into 1 here. First part is find the derivative. Do you all agree that the derivative is 6x squared plus 12x minus 48? Is that good? Okay. Part 2, step 2, sub 2, whatever. Solve. So divide by 6 everywhere. That'll end up getting us here. Yeah.
So part 2 gonna be factoring, right?
Yeah, I'm just combining because last time I did step 1, find derivative, step 2, solve for x, but I'm gonna do it all in one category, just find critical numbers. And this is the 2 things you got to do. So solving for x, is this factor nice? Yeah, we're good, right? Okay. So set this to 0, that 6 doesn't matter. Okay. Step 2. Do first derivative test. Around the critical number, or numbers. All right. So here are the criticals. So plug these into the derivative. Don't matter. What number should we pick? So we got tests before the critical, in between, and after. Let me make that a little better.
-3, -5, 1, and 3.
Okay, -5. We'll test that one. You said 3?
Yes, sir.
Okay. And something in the middle. I guess we could do 0, or do you have a preference? Doesn't matter, right? Yeah, let's do 0. Make this prettier. If you can use 0, recommend doing it because it's easy. So -5. That would be 6 times -5 squared plus 12 times -5 minus 48. So that would be 108, -108 plus that 42. Okay. Yeah. 0. Plug in 0, and we get 48. Plug in 3. $42. All right. So we're decreasing before 4. Still decreasing. Oh no, actually, sorry. Increasing. Positive 42. Decreasing in the middle. And then we change to increasing again. So we got this kind of thing going on, then down, and then up again. So where is the maximum?
I don't think there is a maximum.
We go increasing, then decreasing. We have a local max here.
Okay. So it's at 4?
So at 4 comma something is the maximum. Now, if we're decreasing and then increasing, we create that kind of valley. Country ground. So that'll be a minimum at 2 something. So in order to find the y value, I got to plug it into the original f. To save
Maximum
time.
gonna be -4, right? Or 4.
Oh yeah, -4. Mhm. Yes. So we plug it in, you're gonna get 160 -56. And I'll graph it again so you can see it.
What numbers did you plug in to get the y values again?
So you plug in the x's and you'll get your y, right?
Right.
So just plug this into the original f.
Oh, okay. Okay, I see.
Okay. Now, can y'all tell me where we're increasing?
Hold on. We are increasing at.
I'm gonna draw this better because I feel like that might
I say we are in.
Mhm.
I would say we are increasing at around -5 here. The way you drew it previously. And we're increasing again at +3.
So remember, the change only happens at critical numbers. So
Okay.
and here.
So we're increasing at 2 then.
So everything before 4, we have a plus on it, right?
Mm-hmm.
So everything before here is going up.
Yes.
And then after we're going down.
Mm-hmm.
And then after that, we're increasing again, going up. So before this critical number, we're increasing. So negative infinity up until we get there.
Oh, okay.
And then everything after 2. See what I mean?
Yeah, I see.
Then decreasing. Where does that happen?
That happens at -4 and positive
2?
infinity.
So it goes from, it's only decreasing in the middle, right? In
Yeah,
between
it's only-
critical numbers. Sorry, it's a horrid drawing, my bad. Not your fault. So if you get a positive for a critical number, you can assume everything before that will always be increasing, unless there's another critical number to change that where it could change. Okay. So there's 2 critical numbers here. So in between them, it was negative. Therefore, it's decreasing everywhere in between. After this, we're decreasing. All right, hold on a second.
I have a question.
He's in the
Oh.
middle of something.
Oh, I see.
Sorry about that. Okay.
I have a
Does
question.
that idea make sense?
I have a question. So the decreasing, it says -4, comma 2. Where
Oh,
the
shoot.
2 came from?
Here we go. Are there any questions on example 2?
The 2 came from the 2 is the second critical number, but
Mhm.
And I asked question, it says that decreasing the value is a -4, comma 2, and I asked where the 2 came from. So is it a 2, is it came from the critical value?
Yeah, these are the critical numbers. So I put asterisks here. These are the 2 criticals. So we always test around them.
Oh, okay.
So I got those from here,
Mm,
and then I need to test what's happening before we get there. I got a positive right here.
mm,
So it means I'm increasing up until 4. Then I said, well, let's test any number in between. I chose 0. I got a negative, so that means I have to start coming down after the -4. And then I don't know what's going to happen after 2, so we chose 3. We got a positive, so we'll start going up again.
okay, thank you.
So let's look at Desmos again. So just so we can understand one more time with a prettier picture, then I don't mind if I'll try to draw it better next time. Can y'all see the graph?
Yes.
Sure.
Okay. Let's put negative. And go a little bit. There we go. It's prettier, right? Okay. Did I plug in the right numbers? Oh, no, I didn't. Okay. Now we're good. Okay, so this is the idea one more time. Right. So we have the critical number in -4. So we picked some random number before -4, and we found out that we're positive. So at -5, you get a positive slope. So we can assume everything before that will be increasing forever. Everything after -4, so between -4 and -2, we chose 0 and we got a negative slope. So that means in between two critical numbers, nothing's going to change until they get to another critical number. Once we get there, we could have a change, but it's not guaranteed, so we have to check. So we checked 3 and we got a positive. So everything after is increasing. So we have two sections for increasing. Everything before -4 is increasing. Everything after 2 is increasing. So that's where I got the union part. And then everything in the middle, between -4 and 2, is the only spot where it was going down, decreasing. And when I say down, I mean we have negative slopes. And we always read it left to right. So left to right, what's going on, right? So I picture like, you can picture like a little car going from over here, going up the hill, going up and down the hill, and again, up the hill. So increasing, decreasing, left to right, increasing. So the derivative told me all of this without the picture. Okay, but the picture just so you can see what's going on. Okay. Does that make sense?
Okay, yeah, makes sense.
Yes.
So we're trying to get all this information with derivatives instead of the graph. That's the
I
goal.
have a question. Well, not a question, but it's kind of confusing because the -4 is in the X, but when you write it, it's in the Y because you're going from the negative up into the point. Like, I understand it, but it is just a little confusing. Like, how you put, like, minimum, maximum.
Yeah, so when we put the max, we put the actual point, right? We put the entire -4 and 160. So that's the location of the maximum. But if this function represented something, like if they say, oh, this is max profit, then 160 would be the money, right? Or cost or whatever we're talking about. Velocity, energy, who cares? So X would be the input, Y would be the output. So if they say what is the maximum number of whatever, you'd probably pick this. But we're not doing a word problem yet. So right now it's just, this is where it's at, right there. Okay. Does that make sense or no?
Yeah.
Oh, no, I understood it, but I was just saying that it's just a bit confusing with the X and Y part.
Well, what bothers you about the Y? I guess maybe I don't understand.
No, I get it.
Okay, okay. And any other question?
No.
Okay. Alrighty, so that's 2 examples. That was number 8. Let's do let's do 10. And then I'll let you work on the rest yourself. So given this function, next to the 4th, find the critical numbers first, and then find the intervals increasing, decreasing. C, use first derivative test to find the relative extrema. So that's just a term for relative maximums or minimums. That's it. Okay. All right, so step 1. So what is the derivative?
4x power 3 minus 4.
4x power 3 minus 4. Step 2. That'll be, I'll do it over here. Y'all remember what type of factoring technique we need?
I think it's A plus B times B.
It's gonna be A minus B, so
Yeah,
times
I think it's
squared. Right?
see if I find my notebook.
Yeah, I never remember the cube one either. I might always forget it. Plus minus plus minus plus plus minus. I think it's this. Yeah, here it is. Yeah. So this is the cube one. It's the difference. So this would become x minus 1 times x squared minus x minus, so plus, actually plus Yeah. Does this, can you factor this? No. So we only have one critical point, a critical number. Okay. So let's test around x equals 1 with the first derivative test. First derivative test. Okay. First derivative of 0 would be negative. First derivative at 2 would be I don't care what the number is, it's gonna be positive, right? Okay. So that means we got, try to draw this nice this time. It's going to be decreasing, and then as soon as we get to the critical, increasing. So what is this? What's happening at the critical number? Is it a max or a min?
It's a minimum.
Yeah, it's gonna be a minimum. Do we have a max?
No.
No, looks like there's no more criticals, so, and it doesn't come back down anymore.
Mm-hmm.
That's it. We can answer A and or B and C now. So we're increasing where?
Increasing at 1 and negative. I mean, infinity.
And then decreasing
At negative infinity 1.
max, nope. Minimum will be 1 something, right? I'll look it up just because I feel like plugging it in. 1,4 apparently. Okay, any questions on number 10? Is it making sense?
Yes, it does make sense.
Okay. All right, guys, we'll stop here. Let me take the roll and then we'll see if y'all have any questions about anything. Is Romina here?
Yes, I'm here.
Cade Brown? No, Cade. Megan, Dean?
I'm here.
Alita Felton? Okay, no Alita. Dennis Garcia?
Here.
Oh, there you are. Nigel? Oh, he said he couldn't make it today. Eleni? Eleni Penix? Not here. Matthew Martinez? Matthew's not here. Sarab?
Here.
Brittany Martinez?
Here.
Gabriela Rodriguez?
Here.
Garrett Sadam?
Here.
Haruka?
Here. I'm here.
If you have no questions, we'll stop here. If you do, feel free to stick around.
I have a quick question. From where for minimum, from where we get 4?
Mm-hmm.
From where we
The
get the
minimum?
4? Yeah.
The
It's a
4?
-4 or it's a 4?
Oh, this will be 4. So to get the 4, you gotta do it.
Because when I put the answer 1, 4 into the homework, it says wrong.
Make zeros different. Do you have the same function?
Yes, I think it's the same question.
Have a good evening.
Oh, I'm sorry.
Actually, yeah,
Yeah.
it's not the same question. Sorry.
Sorry, it's minimum. I meant minimum.
Have a good evening, sir.
Oh, good evening.
Thank you.
Thank
Have
you.
a good evening.
Thank you.
All right,
Have a
bye.
good night.
See you later.
Have a good weekend.
Take care.